All right. Hey, everyone. Welcome back. Today we're doing the 11.6 notes, which is on the volumes of cones and pyramids. So if you were here with us yesterday, we talked about volumes of cylinders and prisms, which is almost exactly the same as volumes of cones and pyramids. The only main difference is when you find the volume of a cone or a pyramid, you're taking that volume that you would have had for a prism or a cylinder and dividing it by 3. So here we go. Volume formula, almost the same thing again. Capital B still stands for area of the base. H still stands for the height. Although instead of being the distance between the two bases, this time it's like the distance between the pointy tip and the base. So the distance between the point and the base. And then we divide by 3. So these volume problems are going to go very similarly to the ones that we had yesterday with 11.5. So anyway, on this first one, we have a cone. If you can think of some different cone type shapes, that might help with visualizing. Party hats are a main one, or an ice cream cone, things like that would all be cones. So at any rate, cone bases are circles. So cone, the base is a circle. So the important thing there is being able to find the area of that circular base. So area of the base is still going to be pi r squared since it's a circle. In this case, we're given the radius. It is 3. So we're going to go pi times 3 squared and toss that into our calculator. So we hit the pi button times 3 squared, and then we hit enter. If it gives you 9 pi, make sure you hit that button above the equal sign where it will turn it into a decimal. So you get 28.274. Keep at least 3 decimal places in the meantime. Unless for some reason you end up with less than 3 decimal places, like on some of these other ones with cones and or with pyramids. A lot of times you'll not end up with lots of decimals afterwards. That's okay. But if you have lots of decimals, keep at least 3, since this is not your final answer. All right. So that's the area of the base. The height is that distance between the circular base and the point at the top. So in this case, the height is 8. So now for my volume, we're going area of the base times the height divided by 3. So 28.274 times 8 divided by 3. 28.274 times 8 divided by 3 in the calculator. We get 75.3973 repeating. So now we can go ahead and round to 1 decimal place. So I would probably go with 75.4. And since this was inches and we're still dealing with volume, this is cubic inches. There's our answer. 75.4 cubic inches. All right, so there's the cone problem. Now there's 2 different types of pyramids. So like yesterday when we had 2 different types of prisms, we had rectangular prisms and triangular prisms. Same idea here with pyramids. There's a rectangular pyramid where the base is a rectangle like this one. So we'll start with that. So the base is a rectangle. All right, so what we need to do to find the area of the base is find the area of that rectangle. And again, rectangle area is length times width or base times height, however you like to think about it. In this case, it's 6 times 6, since this one, the base is actually a square. So 36 would be my area of the base. Then the height, again, is the distance between that point at the top and the base itself. And those distances must be perpendicular. So sometimes they'll show that this is indeed a perpendicular distance. It's makes a right angle with the base. So in this case, my height overall for the pyramid is 8. Now we do the same kind of thing with the same formula here, area of the base times the height divided by 3 to get our volume. So it's going to be 36 for area of the base times 8 for the height divided by 3. So into the calculator it goes. 36 times 8 divided by 3. This one comes out nice and even. We get 96. And this one is also cubic inches. All right. One shortcut you could take on a rectangular pyramid, it's not super short, but you could do length times width times height divided by 3. So you could just multiply all 3 dimensions and then divide by 3. But again, that's only something that works for a rectangular pyramid. All right. Next thing, last one is the triangular pyramid. So here we go. This one, we've got this triangle base. And then here's our height, that distance from the tip to the base. So for a triangular pyramid, again, the base is a triangle. So for this one, we have to use for our area of the base formula, base times height divided by 2. So if we're looking at just the base and figuring out the area of this triangle, we have to go 8 times 14 divided by 2. Remember, the base of the triangle and the height of the triangle have to be perpendicular. They have to meet at a right angle like these ones do. So at any rate, 8 times 14 divided by 2 into the calculator is 56. Then my overall height for this pyramid is 17. That's the distance again from the top to the bottom. So putting it all together, volume, base area times the height. So 56 times 17 divided by 3. So now we go 56 times 17 divided by 3 in the calculator, and we get 317.3 repeating. So in this case, I'm okay with rounding to just 317.3. And this one is just going to be units cubed because we aren't told what kind of units this is. This could be feet, miles, inches, centimeters, millimeters. But anyway, not squared, sorry, cubed. Goodness, did I say squared? I don't know. All right, anyways, units cubed. So 317.3 units cubed. And that's pretty much how cones and pyramids work. Today's homework is going to be IXL. It's going to be the volume of cones and pyramids unit in IXL. So you're getting to a SMART score of 80 and then you can be done. If you guys have questions or need help with anything, I will be back on Monday. So I'll see you then. Please hold your questions till then or ask someone nearby. I'm sure someone else in the room can help you out. So help each other out, please. All right. Have a good weekend.